Hello everybody, it is time to learn how to do some calculations that involve probabilities for the normal distribution. Now, before I tell you how to do that, I want to tell you where I left it at the last video. So suppose you have some data and you know it's normally distributed and you know the mean and you know the standard deviation, okay? Those are three basic uh, what's the word? Three basic facts about data that can really help us out, okay? That it's normally distributed, that we know what the mean is, and that we know what the standard deviation is. And I can, with those numbers, calculate probabilities that the data is a certain way, okay? So this was an example I ended with my last video. I didn't tell you how to do the calculations though. But like I said, I mean, once we know that data is normally distributed and we know the mean and we know the standard deviation, the important thing to learn how to do from there is to measure areas on that curve. So here I said, you see, here's the curve for this data where people rank their happiness on a scale from 0 to 10, okay? And as a matter of fact, the area under that curve from 6 to 8 is 0.26. So that's like a basic kind of calculation that we need to do. It happens to mean that the probability that a random person's response ranking their happiness was between 6 and 8 is 26%, okay? If we just select somebody from that survey pool at random, there's a 26% chance that they rank their happiness somewhere between 6 and 8. So yes, like once we know that data is normally distributed, knowing how to get that number is one of the most basic and important things that we need to know to learn how to do, okay? Now, ways we could do that. We could use StatCrunch. That comes with my math lab. If you're using my math lab anyway, you could actually do it on Excel. There are tables. You can use a handheld calculator and so on. All right, let's just use StatCrunch because it's something that I believe everybody would have access to. Okay, but let's do like a basic question. Okay, so here this one says, calculate the area under the standard normal curve to the left of z, which is just a point on the curve, negative 1.84. Now, first of all, so every normal distribution has a mean and a standard deviation. The standard normal has a mean of 0 and a standard deviation of 1, okay? So here I have this graph for you and I have my answer. And here it is, like z being negative 1.84 is about right there. It's a little bit to the right of negative 2. Highlighted in red is the area under the curve that we're talking about, and it happens to be about 0.0328 or so, okay? 329 if you round it. Here's how I got that number. So let's go to here. I'm in my math lab at this point, and I'm just going to open StatCrunch because that's where we'll do this. And here's how we could do calculations with the normal distribution. Go to Stat and Calculators, and then down here you see normal. Okay. Now, the standard normal, what did I say? It has a mean of 0 and a standard deviation of 1. Okay, so the default when you bring this up is the standard normal. And that number was what? It says calculate the area under the curve to the left of negative 1.87. So the way that that's going to look when you type it in is P for probability. Because on this curve, the area under the curve is the same thing as the probability associated with it, less than, and then it was negative 1.87, all right? And then there's that number. Did I remember that right? 1.87, I'm sorry. 1.84, 1.8, but you get the idea. You just type in the number, 1.84. There we go. Compute, yeah, 0.03288. All right, that's how I got that number. And I just, when I was wanting to make this video for you, I just imported the graph into the document, but there it is. All right. Okay, so there, I'll copy that number right there. That's it. That area right there that was asked for and indicated in this question, 0.0329. Okay, so all right, yeah, not so bad. Okay, let's look at another one though. Can you calculate the area under the standard normal curve between 0 and 2.07? Okay, now remember again, the standard normal curve is a normal distribution, a normal curve with a mean of 0 and a standard deviation of 1. So the mean of being right in the middle there, remember at the peak. So yeah, the 0 is right in the middle. Now visually, the way this would look if I said, well, I'm talking from 0 to 2.07 is like this, right? There's 0, and then 2.07 would be just a little bit to the right, okay, of 2. And that's what it would look like. Let me show you how to do this calculation. I'm getting that it's going to be 0.4808. How I got the calculation is I again go to StatCrunch, I go to Stat, Calculators, Normal, and then it said, remember the wording was a little bit different. It said we want to be between, like what's the area between 0 and 2.07? So we want to select this between option because as it is, it won't let it, I can't directly type in between this number and this number. So I just between, okay, so it was 0 and 2.07. All right. And I compute, there's that same picture that you saw on my document. And all right, I'm going to go back over to the document now, same picture. The probabilities, same thing as the area under this curve between 0 and 2.07 is 0.4807. All right, if you round it, 0.4808. Yeah, so let me tell you, StatCrunch makes this very easy to do. Now, there's, let me see. Okay, so there's nothing to this part of it. I mean, this is something we have to learn. It's just a stepping stone along the way, but nobody really cares that much if you can calculate the area under a certain part of the standard normal curve. We need to put this in context of something, okay? Like some kind of data, or we're making a prediction of some kind, okay? So here's an example then, all right, where we can put together all this. What we know about the normal distribution, the way we think about it, and how we do the calculations. We can put it all together right here. Okay, monthly utility bills in a city are normally distributed. All right, so we know the bell curve applies to it. We can do calculations with the normal distribution StatCrunch if we need to. So that's what that tells us. In order to really do that, though, we need to know the mean and standard deviation. So the mean is $100 and the standard deviation is $16. Okay. So like the mean being $100 means, most people's utility bill each month is around $100. Okay. The standard deviation is, well, we talked about the standard deviation for the first time a long time ago, but it's when I first, do you remember, I'm going to get off on a side topic for just like 30 seconds, but do you remember when we first learned about the standard deviation? What do we say that it was? Say, well, that tells you how spread out the data is, okay? The mean tells you where the data is, and the standard deviation tells you how spread out it is, right? Because data is are numbers, and numbers have to be somewhere. And the mean tells me where they are, and the standard deviation tells me how spread out they are. Okay, so basically that's the significance of those numbers. Now, so say we know that normal distribution of utility bills. Mean is $100, standard deviation $16. Can you calculate the probability that a randomly selected utility bill is between $80 and $90? Okay. Now, here you see something that looks like it was imported from StatCrunch, and that's because it was imported from StatCrunch. So, but let me show you how I got it. Okay. So, let me do this. I'm going to go to StatCrunch. Now, um, what were we dealing with? Normal distribution, and it said the mean was $100. I'm going to put 100 in. And it says the standard deviation was $16. Okay? And then the question was, can you calculate the probability that a random person's utility bill was between 80 and 90? So it's like the X is the number or the spot on the horizontal axis, and to cover between 80 and 90 sweeps all that out. All right. So there it is. Okay, that's the graph that you just saw in my document. But I had to select the normal distribution calculator, and I had to put the mean and the standard deviation in for whatever they're supposed to be. Okay, all right, so there's your answer. See that number right there? The area here is 0.1603. Areas are equivalent to probabilities. So the odds of a randomly selected person's utility bill being between $80 and $90, with that decimal being the area, convert 0.1603 to a percent, 16.03% chance. Okay. All right. Now let's see like one more variation on this question. What are the odds that you select a person at random in the city and their utility bill is more than $110? Okay. All right. Well, let's go back to StatCrunch. And if I want to know the area under the curve more than 110 or to the right of 110, the between option is not going to do it. So I go back to standard. I change this inequality to greater than, and then the number was 110, right? There it is. All right. And it always shows you the graph to make sure that you're looking at the right thing. Remember, the question was, what are the odds that a randomly selected person has a utility bill more than 110? So this is to the right of that. That would be more, right? So this graph should always look like what you're trying to calculate. But there it is. And here's the same graph imported into my document. So it says that the area there to the right of 110 is 0.2659. Okay, if I convert that to a percentage, it's about a 26.6% chance if you select somebody at random. But that's how their utility bill is going to turn out. All right, so that's how we do our basic calculations with the normal distribution. Let me tell you, StatCrunch makes it very easy to do. I really think that it just helps to know what you're looking at when you see these curves, and that you can, in your own mind, make sure that when you see it, it does match up to whatever you're trying to calculate.